All right, picking up back where we left off. Let's see, we just finished number 6. So here we got number 7. So it says, for the functions below, use transformations, or for the function, use transformations to sketch the graph of f of x minus 3 plus 2. So this function has two transformations. The first one is this guy right here, and that is a shift. Anytime you see plus or minus, it's a shift. It's also inside the function, which means it's horizontal, left or right. A minus means to the right. So it's been shifted right by 3. Then we got this plus 2 on the end, and this plus 2 is also a shift because it's a plus or minus, but it is outside the parentheses, outside the function. So it's vertically, it's up or down, and a plus means up. So we're going to take this function graphed here, and we're just going to move it right 3 and up 2. So I'm just going to pick a few important points. For example, I might do this guy, and this guy. Those are kind of the easiest to see what's going on. And then I'm going to shift them left 3. So let's see. This bottom point moves 1, 2, 3, moves to right here. This point on the right moves left 3, that's right here. And this point way over here, left 3 is going to be off my graph, but not off very far, so I'll just draw it kind of in the air. Okay, so this is not the final answer, but it is the graph that's been shifted left by 3. The next thing I need to do is just move it up 2. So again, I'll take each point and I will move them individually up 2. So this first one moves to right here, or the bottom one, excuse me. This one moves up 2. The next one moves up 2 to right here. And then this one moves up to 4. And there we have it. The final answer is our green function. Well, actually, instead of labeling it final answer, I'm just going to put it over here on this graph. Where was it? It was started it here, and we moved it left 3 and up 2. There we go. Okay. Next, graph this function f of x equals 1 over x minus 2 plus 3 by applying transformations to f of x equals 1 over x and give equations of the asymptote. The first thing I'm going to do is graph the original function, that 1 over x. It's also known as the parent function. And to do that, like always, I'm just going to make a little table. We've got x and we got y. Easy numbers to plug in are going to be negative 2, negative 1, 0. And I'm going to do 1/2 and then 1 and then 2. I should have done negative 1/2. It's a little easier to see what's going on if you include those points. Whoops. Negative 1, negative 1/2, 0. There we go. Okay, if you plug in negative 2, you get negative 1/2. If you plug in negative 1, you get negative 1. If you plug in negative 1/2, you get negative 2. If you plug in 0, you get undefined. Problem. If you plug in 1/2, you get 2. If you plug in 1, you get 1. If you plug in 2, you get 1/2. Okay, so I'm going to graph each of those points. Let's say this is like 1, this is negative 1. So each square is 1/2. That'll be a little easier for me to graph it. So negative 2 is going to be out here. Negative 1/2 is right here. That's my first point. Then I've got negative 1, negative 1. That's right here. Then I've got, well, on the y-axis, I should label those 2. Here, this guy is 1, this guy is negative 1. Then I've got negative 1/2, negative 2. That's right here. At 0, it's undefined, which means I have an asymptote. So I'm going to draw my asymptote. And then I can keep going. My other points are going to be, let's see, 1/2, 2. So that's right here. And then 1, 1, that's here. And then finally 2.5, that would be right here. So when I connect these with a smooth line, they end up looking something like this. And it turns out there is another asymptote right here. The reason for this other asymptote is because if you look at the y column and ask yourself, what number in the y column would give us a problem? Like, what number can we never get? And the answer is 0. No matter what you plug in for x, you will never make this equal to 0. 1 divided by even 1,000, it's a small number, but it's not 0. 1 divided by 10,000, small number, not 0. Turns out there's no number that will give you 0. So we've got another asymptote. So, okay, this is our original function. I am going to make a copy of it because that's going to be the easiest way. I will put this down below. And what we're going to do is apply two transformations. Here are the two transformations. This one is a shift because it's plus or minus. It's inside the function, which means it's horizontal. It's left or right. And the minus means to the right. So we're going to shift it right 2. And this, as we said before, outside the function, it is a plus, which means it's up, it's vertical, and it's by 3. So we're going to take this exact function, and all we're going to do is shift it right 2 and up 3. So let me show you. I'll take this function along with the asymptotes. Oh wait, hang on, I think I can grab all of it. Take this function and its asymptotes, but not the graph. Let's see if this will work. And I'm going to shift it to the right by 3, to the right by 2, and up 3. I think I did it. Is that what it said? Right 2, up 3. Is that what I did? Oh no, hang on, let's go back. I forgot. Each square is half of a point. So let's try one more time. This is right 1. This is right by 2. This is up 1. This is up 2. This is up 3. There we go. I think that's it. You could check it by doing individual points. For example, this point right here, if you move it right by 3, no, it's right by 2, isn't it? Right by 2, and then up by 3, it'll end up right here, which is the point, let's see, that's the point 3, 4. And down here, let's check it. Does it look like 3, 4? Well, this is 2, this is 3. Yeah, that's 3. Yeah, I think that's 4. Okay, so it looks good. We checked it, we're good. So yes, final answer looks like this. Okay, determine algebraically whether the following functions are even, odd, or neither. The rule is this: if f of x equals f of negative x, it is odd. So if you plug in a negative x and you get the same thing, oh, I'm lying, it's even. It is even, sorry. If you plug in a negative, so if you plug in a negative and you get almost the same thing except the whole thing has been multiplied by a negative, that is an odd function. If it doesn't do either of these things, it is neither. So for all of these functions, the way to test if it's even, odd, or neither, you plug in a negative x. So in this case, I will plug in negative x here and a negative x here. Now, a negative x to the 4th, that means a negative times negative times negative times negative. There are 4 negatives, they will cancel each other out. This is the same as 3x to the 4th. Over here we got 2 negatives. 2 negatives multiplied together make a positive. They will also cancel each other out. And this, you may notice, is exactly what we started with originally, which means plugging in a negative changed absolutely nothing. So this is an even function. It matches this definition. For part B, we're going to follow the same thing. Plug in a negative, see what we get. So we've got 2, and then I'll plug in a negative x to the 5th, plus negative x. Well, let's see. If we multiply 5 negatives together, 4 of them will cancel out, but 1 will be left. So this will be left as a negative. And right here, plus a negative just means minus. Now, compare this, negative 2x to the 5th minus x. Compare it to this. It's exactly the same, except the whole thing has been made negative. That's this definition. Exactly the same, except the whole thing is negative. That's what this guy says right here. That is an odd function. Finally, for number C, or part C, we're going to plug it into this. So we've got 7x squared plus 5x minus 1. So 7, plug in a negative, x squared plus 5x, negative x, excuse me, minus 1, because we're copying it, except we're plugging in a negative. The first one, let's see, negative x squared, those will cancel each other because we got two negatives. This one is just the same as minus 5x, and then we got a minus 1. Compare this to our other function. It is not exactly the same. It's a minus 5x instead of a plus 5x. But it's also not the whole thing multiplied by a negative. Only pieces of it have been multiplied by a negative, which means this is not even nor odd. It doesn't match either definition. It is neither. Okay, number 10, find each of the following. Okay. Well, when it's written like this with parentheses, f plus g of x, that just means this, f of x plus g of x. This is the same as this. So we are going to just copy f of x and copy g of x. So f of x is this guy, x squared minus 9x, and then we add 2x plus 3. We see if we can simplify, but this is it. This is basically the final answer. And it turns out I can simplify. Negative 9x plus 2x is minus 7x, and then we've got plus 3. And that's A. We just add them together. For part B, we're going to do the same thing, but we're going to subtract them. So we'll have x squared minus 9x, and then we do minus parentheses 2x plus 3. The parentheses are very important. Anytime you're plugging in anything, just put parentheses. It's always safer to plug in with parentheses. I have to distribute this negative. That's why the parentheses are important, because it's got to be distributed. And then I'll have x squared minus 9x minus 2x plus 3. When I combine my like terms, I get x squared minus 11x plus 3, final answer. Part C, when it's squished together like this, it means multiplied. So here, we want to multiply x squared minus 9x times 2x plus 3. To do that, I'm going to FOIL. So I'll do first times first. Yeah, first times first, outside times outside, inside times inside, and last times last. So first times first, that is x squared times 2x, that is 2x cubed. Outside times outside, that's x squared times 3, that's plus 3x squared. Inside times inside, make sure you include your negative. Negative 9x times 2x is negative 18x squared. And again, make sure you include your negative. Negative 9x times 3 is negative 27x. I can combine my like terms in the middle, but I'm basically done. This is 2x cubed. 3 minus 18 is going to be negative 15x squared, and then minus 27x. All right. Let's see. D. They are divided. Exactly the same thing, but let's see. We've got f on top and g on bottom. Make sure you know which is which. So f of x is this x squared minus 9x, and g of x is this 2x plus 3. Now I should check if this simplifies. So to do that, you have to factor and see if anything cancels. But I know pretty much right away that nothing will cancel because almost nothing factors. The only thing that I could factor is the top. I could take out an x. But even if I do that, look, they have nothing in common. Nothing simplifies there. So the final answer is x squared minus 9x over 2x plus 3. For part E, okay, this G, this stands for the word of. GF, or it also means composed with. That's the official mathematical term, but I like to think of it as of. G of f of x. So normally we say f of x, and that means take x and plug it in. This means the same thing. G of parentheses f of x means take f of x and plug it into g. It's the same language. So we're going to take the whole function f of x, which was what, x squared minus 9x? We're going to take this guy and we're going to plug that whole thing into g of x. And g of x is, it was 2x plus 3, is that right? Let me check. Yes, 2x plus 3. So we're going to take this and we're going to plug it in for x. So here's what we'll have. We'll have 2x squared minus 9x plus 3. I can simplify this a little bit. Maybe I should have labeled this. This was part E. Part E. I can distribute this too, so I'll do that. I'll distribute this too, and then see if I can combine any like terms, and then I'll be done. So that's 2x squared minus 18x plus 3. No like terms, I'm done. F is exactly the same thing, except we've switched the order. So read that as f of g of x. So this time we'll take g of x, which is 2x plus 3, and we'll plug it in to f of x, which is x squared minus 9x. It is, right? Yes. So we're going to take this guy and we're going to plug it in everywhere we see an x. So we will have parentheses 2x plus 3 squared minus 9 times 2x plus 3. So all we did was we took g of x and we put it inside of f of x. I can simplify this. To simplify that first 2x plus 3 squared, I'm going to have to FOIL. So that will give me 4x squared. I'm going to do it in my head. You can write out the FOIL. Plus 12x plus 9. And then I'm going to take this negative 9 and I'm going to distribute. Here, I'll write FOIL. That's what I did to get from here to here. Negative 18x minus 27. Then I combine my like terms and I'm done. So it will be 4x squared plus 12x minus 18x, that's minus 6x, plus 9 minus 27, that's minus 18. Done. All right, number 11, solve this. 2x squared plus 16x plus 26 equals 0. Two correct ways to do it. I will accept either happily. Most people will accept either. Option 1, factor it. Option 2, quadratic formula. If you got a calculator, quadratic formula might be faster. I'm going to show you how to factor it. So we've got 2x squared plus 16x plus 26 equals 0. Now, I always use the same factoring method. So here's my factoring method. Step 1, multiply the first coefficient times that last number. So when I do that, I get 2 times 26. Well, let's see. That is 52. So I write down 52. And then maybe I should do it in a different color to be clear. Then I ask myself, what times what equals 52? That also, those same two numbers add together and make 16, the middle coefficient. So let's see, I have to think about this for a second. It's 6 times 10 obviously won't work because that would give me 60. Let me try factoring my 52. So that is 13 times 4? 13 plus 4? No, that's 17, so that's not going to work. Hang on. You know what? I can't think of any numbers. Here, I'll make a complete list. 52 has these factors. It's got 13 times 4, it's got 26 times 2, and then it's got 52 times 1. And I don't think there's anything else. So none of those add up to 16, which means we're going to have some trouble solving it this way. So I'm going to put question mark, question mark. We couldn't do it. Well, not question mark. We know it has no answer. So maybe we'll cross it out. We'll say that didn't work. No numbers. No, can't factor. Let's write that. Can't factor. So, okay, instead, we're going to go for method 2. Method 2 is the quadratic formula, which is this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 2, b is 16, and c is 26. So let's see, that will give us x equals negative 16 plus or minus the square root of 16 squared minus 4 times 2 times 26, all divided by 2 times 2. Well, let's see. The hard part inside of the square root is going to be 16 squared is 256. And then we already did 2 times 26. That was 52. Then we're going to have to multiply it by 4, which is 208. You could do that on a calculator if you have one. Plus or minus, and it's all going to be divided by 4. So let's see. 256 minus 208 is going to be 48. So that makes sense. That is not a perfect square. It means it doesn't have a beautiful square root. So there's not really a good way, there's not a rational answer is the solution to that. But let's see if we can simplify that square root. 48 divides by 16. So I'm going to split it up. I'm going to do 16 plus or minus, and then this will become square root 16 square root 3. Because 16 times 3 is 48, so it splits like that. And then we can go ahead and take the square root of 16, which is 4. So we've got 16 plus negative 16 plus or minus the square root of 4 root 3, and then divide it by 4. Final step, I'm going to divide everything by 4. So this is negative 4 plus or minus the square root of 3. And that's our answer. Makes sense that we couldn't factor. There was no rational solutions. That's why. All right, number 12. A ball is thrown vertically upward from the top of a building 800 feet tall. Distance is given by that function. What's the maximum height? When will it hit the ground? Okay, here's what I'm going to do. First, draw a little picture. This is a building. This building is 800 feet tall. The ball gets thrown off the building. Hang on, it will snap to in just a second. Come on, friend. There we go. The ball is thrown off of the building. Something like this. The question is, what is this value, the maximum height, and what is this value, what's the x value here? So it'll always be the time and then the distance. The time that it's taken and the distance from the ground. That's the x and the y. So they want to know what is this time down here and what is this distance up here. This shape, you may know, is a parabola. If you didn't know that, you can look right here. That is a quadratic, which means the shape of its graph is a parabola. So the maximum height, the maximum value of a parabola, I'll write this sentence down. The max value of the maximum point, that's what I should say. The maximum point of a parabola is its vertex. Always. And the vertex we've got an equation for. The equation for the x value of the vertex is negative b over 2a. In this case, though, I probably shouldn't call it x. I should probably call it t, because that's what we're using instead. But it's going to be pretty simple to figure out. So let's see. Our equation is this, 800 plus 80t minus 16t squared. But please note, it is out of order. In proper order, it would be this. D of t equals negative 16t squared. That's in the right order. You always put it in highest exponent to lowest exponent order. So let's see, negative b is going to be negative 80 divided by 2 times a. A is negative 16. Well, let's see, when I simplify that, I get negative 80 divided by 2 times 16 is going to be 32. Oops, divided by negative 32. And then let's see, 80 divided by, or negative 80 divided by negative 32 is going to be 2.5. So that is the x value, or the t value of the vertex. To find the y value, the actual distance, we just have to plug it in. So this is the amount of time it took to reach its maximum. To find how high it got, we just plug it in. So d of 2.5 is going to be equal to 800 plus 80 times 2.5 minus 16 times 2.5 squared. And from here, I would definitely do this in a calculator. And let's see, I've got one with me. So this first part is just 800. 80 times 2.5 is going to be 200. And then let's see, 2.5 squared is going to be 6.25 times 16 is going to be 100, so minus 100. Ah, that's nice and pretty. 800 plus 200 is 1,000, minus 100 is going to be 900. So the highest it got is 900 feet off the ground. The next question is, when does it hit the ground? Well, that is whenever this y value is 0. This d is 0. It's 0 distance away from the ground. So we're just going to take our distance equation, d of t equals 800 plus 80t minus 16t squared, and we're going to set it equal to 0. Here, let me give a little space to be clear. This is a second problem. And once you set it equal to 0, we just solve it like normal. So the first thing I notice is that everything here is going to divide very beautifully by 16. That 800, that 80, and the 16 all divide. So when I divide everything by 16, I get 50 plus 5t minus t squared equals 0. Then I'm going to rearrange it in the proper order and by moving everything to the right-hand side. So technically I did plus t squared, and then I did minus 5t on both sides, then I did minus 50, and on the other side, it's equal to 0. Okay, once I do that, I can factor it, and I can follow my same process as above. Blank times blank equals, I can multiply my first coefficient times the last, but the first coefficient is 1, so it'll still be negative 50. And then blank plus blank equals negative 5. Well, the two numbers that do that are going to be, it'll be some combination of 10 and 5. You might be able to tell that right away. And the 10 has to be negative because negative 10 plus 5 is negative 5. So that means it factors like this. T minus 10 times t plus 5 equals 0. If two numbers multiplied equal 0, that means one of them had to be 0 to start with. So either t minus 10 equals 0 or t plus 5 equals 0. If I add 10 to both sides, I get t equals 10. If I subtract 5 from both sides over here, I get t equals negative 5. Now, which one is our answer? Let's go back to our diagram. So remember, t is just like x. So this guy over here on the right is going to be 10. And if you extended the parabola backwards, this guy over here would be negative 5. But clearly it can't actually go back in time, which means negative 5, while it may be mathematically correct, is not a valid answer to this word problem. The one we're looking for is 10. After 10 seconds, the ball will hit the ground. So we're going to cross this one out. This is our answer. Number 13, we've got a profit function where x is the number of items sold and p is the profit from that sale. So we're supposed to find the maximum profit and the number of items that must be sold to reach that profit. Well, let's see. Again, this is going to be a parabola, and because my x squared is negative, it will be an upside down parabola. So we can draw a quick sketch of that just so we know what we're working with. Looks something like this, and we're looking for this value right here, which again, that's just the vertex. And we've got an equation for a vertex. The x value of a vertex is negative b over 2a. And in this equation, it is in the right order. Very nice. So we're just going to straight up plug things in. negative 90 over 2 times negative 1. Well, that's just negative 90 over negative 2, and if I divide 90 by 2, I get 45. So the answer is X is the number of items sold. So 45 items must be sold to hit the vertex. 45 items must be sold to reach maximum profit. To find what that profit is, we just take 45, we plug it in. So we would say P of 45 equals negative 45 squared plus 90 times 45 minus 300. And again, when it gets just a little complicated like this, I would go ahead and use a calculator. So let's see, negative 45 squared, negative 2025. And then let's see, 90 times 45 is going to be 4,050. And then we've got minus 300. So let's see. Combining these first two numbers, I get 2,025 minus 300. That is just 1,725. Pretty sure. Hang on, let me just double check that with my... No, I'm positive. All right, so this in dollars is going to be our max profit. And it takes 45 items to get to this point. So let me label that. Max profit, $1,725. Number of items, 45. Done. All right, number 14. Analyze this polynomial and complete the chart below. State the degree, determine the end behavior, just determine the end behavior of the graph. Okay, I'm going to extend this table because I think we need a few different things. I want to list the zeros one on top of another. So let's see, it says list the zeros, that's fine, whatever. List the zeros first, and I see 3 zeros, so I really only need 3 rows. That's fine. Okay, so looking at that function, there are 3 linear factors multiplied together, and if I set each one equal to 0, so I could do x minus 4 equals 0, and x plus 1 equals 0, and x plus 3 equals 0. And if I solve all of those, I would get 4, negative 1, and negative 3. The multiplicity of each 0 is just the power that it's raised to. So the negative 4, or the 4, is raised to the 3rd power. The negative 1 is raised to the 2nd power. The negative 3, its linear factor, is raised to the 1st power. So does the graph touch or cross? Well, the rule is that it touches if the multiplicity is even. It crosses if the multiplicity is odd. So this first multiplicity is odd, which means it crosses. The second multiplicity is even, which means it touches. The third multiplicity is odd, which means it crosses. To determine the end behavior, or actually state the degree first, that will tell us about the end behavior. So the degree is all of these things multiplied together, which means our biggest term will come from multiplying the 7 times x cubed. It's plus a bunch of other stuff, like it'll be x cubed plus stuff, but all the other stuff is smaller, so I don't care about it. It's not going to be the leading term. And if you remember, the only thing we care about for finding end behavior is the leading or the dominant term. So just pull out the dominant term from each of these. That means this guy's not the dominant term, this guy's not the dominant term, this guy's not the dominant term. You can ignore those. I'm going to erase that so it's clear what I'm doing. Just the x's are the dominant terms in each. So we'll have a 7x cubed, we'll have times an x squared, and we'll have times an x. When you multiply all that together, you get 7x to the 6th. So that is going to be our dominant term. 2 important things about it. It is positive, and it has an even degree. If the degree is even, that means the end behaviors are the same. So the even degree looks like this. Well, it can do all sorts of stuff in the middle. I don't really care what it does in the middle, but the end behaviors are the same. Even degree means one of these two things. Even degree. I'm moving it so it's clear what we're looking at. If it's positive, it goes up on the right-hand side. So you can write that like this. As x goes to infinity, f of x also goes to infinity. As x goes to the right, the function goes up. So we know these two things. That means there's a really obvious picture. It's got to be this guy. Both ends go up. So let me write that officially. The end behavior is, and I'll write that first one as I have it above. As x goes to the right, f of x goes up. And as x goes to the left, remember the degree is even, which means the ends do the same thing. So, I forgot to write left. As x goes to the left, make that negative. It also goes up. They both go up. And we're done. That's the end behavior. All right, number 15. When a person gets a single flu shot, the concentration of the drug is given by the following equation. Find the horizontal asymptote and interpret what it represents. Got it. Okay, so here's our function. 7.6t over t squared plus 0.2. Well, it says find the horizontal asymptote. Here are the rules for horizontal asymptote. You find two things. First, n, which is the degree of the numerator. The degree of the numerator in this equation is 1. D is the same except denominator. It is the degree of the denominator. And in this case, it is 2. Then you check. If n is less than d, which it is, n is less than d, there is a horizontal asymptote at y equals 0. That's the rule. I listed these rules somewhere elsewhere. You can check back, see if you can find those notes. But if n is less than d, there's a horizontal asymptote at 0. Actually, I'll just write the others. If n is equal to d, horizontal asymptote at the ratio of the coefficients. That just means the ratio of the leading coefficients. So like it would be 7.6 over 1. But it's not because the t is not squared. N does not equal d. If n is greater than d, no horizontal asymptote. Those are the rules. So in our case, we're this guy. It's at y equals 0. That means our graph does something like this. So if this is a graph, I don't know what all happens over here. It doesn't matter. But here's what I know. On this hand side, it does this. It gets closer and closer and closer to this horizontal asymptote, but it never actually touches it. That means my function, my concentration of the drug per liter, milligrams per liter, but it's just the concentration of the drug. The concentration of the drug gets closer and closer to 0, but it never actually touches 0. So that's the interpretation. The concentration of the drug we would say mathematically it approaches 0, but it never reaches. And there we go. That's the interpretation of my horizontal asymptote. Okay, number 16. For each rational functions below, find the equations of the vertical asymptote and the horizontal asymptote. Okay, the rule for vertical asymptotes is that they happen whenever the denominator equals 0. Because remember, the denominator is not allowed to equal 0. So I'll go ahead and write it like this, just so it's clear. The denominator cannot equal 0. This is the place that the function never touches. So that's why it will give us the vertical asymptote. So I'm going to add 1 to both sides, and I'm going to divide by 1/2. So in the function, x never equals 1/2. I guess I can write it without this. We're just looking for the point that it doesn't happen. The point that the function never crosses, never touches. So this net function never touches x equals 1/2. That means there's a vertical asymptote at x equals 1/2. There's a horizontal asymptote. Let's see. N is 1, D is 1. Here, I'll write that. N equals 1, D equals 1. Those are the same. The horizontal asymptote is at the ratio of the leading coefficients. That is 5/2. Horizontal asymptote at y equals 5/2. Part B, let's see, we've got 7x over x squared minus 1. We're going to do the vertical asymptote the same way. We'll say x squared minus 1 equals 0. That's the place that the function can never actually reach. Add 1 to both sides. I get x squared equals 1. Take the square root. You got two answers, 1 or -1. So we've got a vertical asymptote at x equals 1 and x equals -1. I can't hit either of those places. The horizontal asymptote, let's see, n equals 1, d equals 2. D is greater than n. That means the horizontal asymptote is at y equals 0. Part C, same steps. For the vertical asymptote, we would set the denominator to 0. So there's a problem when 3x plus 2 equals 0. Subtract 2 from both sides, I get 3x equals -2, x equals -2/3. So we've got a, not horizontal, we've got a vertical asymptote at x equals -2/3. For the horizontal asymptote, n equals 3, d equals 1. N is greater. If n is greater, there is none. Okay. Number 17, find all of the complex zeros and then write the function as a product of linear factors. Okay, to do this, I am going to factor the function as much as possible. If there are if there are complex zeros, I will find them using the quadratic function. So first, I'm going to factor it. These all have an x cubed in it, so I'm going to take out an x cubed. And then what I have left is 2x squared plus 12x plus 18. For this piece of it, this is where we possibly, have complex zeros. So I'm going to go ahead and factor that part of it using the quadratic formula. So I've got x equals negative, well, b is 12, plus or minus the square root of 12 squared, minus 4 times 2 times 18, 4ac, all divided by 2 times 2. Okay, let's see. So then I simplify what's inside of the square root, and when I do that, 12 squared is 144. 18 times 2 times 4, hey, that is also 144. This subtraction will not give us a negative number. That means we won't have a negative number under the square root, which means we won't have any complex zeros. So I can finish this, but I'm basically done. This is -12 plus or minus 0 divided by 4. That's just -3. So it turns out it will factor. So I'm going to go ahead and write there are no complex zeros. It factors as x plus 3 times x plus 3, but I'm going to go back up and factor it using the x's. There are no complex zeros. That's what I learned. So let's go back to this guy and factor it. Well, you know what I noticed? I should have taken out a 2. Let's take out a 2. And then what we have left is x squared plus 6x plus 9. That would have made my life easier because this I recognize as x plus 3 squared. X plus 3 squared, which makes sense because my 0 was -3. You set this equal to 0, you get -3. That lines up. And there was a plus version or a minus version which means it was squared. That's basically what that is. So this is the answer. F of x is equal to this. There are no complex zeros. All right, find all the complex zeros and use the rational zeros theorem to list all possible rational zeros. Okay, I'm going to do the rational zeros theorem first. Here is how we find rational zeros. Look at the constant term, the negative 20, and look at the first coefficient, which is 1. All rational zeros, rational zero candidates, I guess, all rational zeros are fractions. The top of the fraction comes from negative 20. It's a factor of negative 20. So let's list the factors of negative 20. That is plus or minus 1, plus or minus 2, plus or minus, let's see, 4 is a factor of negative 20. 5 is a factor of negative 20. 10 is a factor of negative 20. And 20 is a factor of negative 20. And I think that's it. Those are all the possible factors of 20. The possible factors of the denominator, that's the top of my fraction. The bottom of my fraction literally comes from 1, which means the factors of 1 are literally just 1. So the denominators of all of my fractions are going to be 1, which means I don't have anything new happening here. 1 over 1 is still 1, 2 over 1 is still 2. So these are all of my rational zero candidates. Now, to find out which ones are actually 0, I should plug them into my function. So I should look at f of 1 and f of negative 1 and f of 2 and f of negative 2. And I would do all of these using your calculator because it's going to be kind of tough to do it in your head. So let's see. I'm just going to do the first couple because I think I know how it's going to turn out. So I'm going to skip a few steps. Well, let's see. If I plug in a 1, I think I get negative 10. If I plug in a negative 1, let's see, that would give me 1, and then plus 7, and then plus 14. Oh, and then minus 2 and minus 20. That gives me 0. That's great. We have one of our rational zeros determined. It is negative 1. And I think if I plug in 2, I also get 0. And you know what? That's enough. I only need 2 of them. Here's why I only need 2. This is a 4th degree function, which means it has 4 possible zeros. At most 4 zeros. I got 2 of them, negative 1 and 2. I found them. If there are more, you can always find them using the quadratic formula. That's the rule. The last 2 zeros you can always find using the quadratic formula. And my gut says that because they say find the complex zeros, there's a decent chance that there will be complex zeros, which means I'm probably going to have to find them using the quadratic formula anyway. So let's just stick with, I got these 2. I'm not going to worry about this. So here are my zeros, negative 1 and 2. So from here, what I got to do is I got to take this x to the 4th minus 7x cubed plus 14x squared plus 2x minus 20. And I've got to divide it by the linear factors given to me by these zeros. Well, if f of negative 1 equals 0, so negative 1 is x. If I add 1 to both sides, I get x plus 1 equals 0. This right here is a linear factor. So I'm going to divide this guy by x plus 1. Let's see, when I do that, I say how many times does x go in x to the 4th? Well, it goes in x cubed times. X cubed times this guy is x to the 4th plus x cubed. Subtract that, I get negative 7 minus x cubed, that's negative 8x cubed. And then I bring down the plus 14x squared. How many times does it go in? Well, it goes in negative 8x squared times. Multiply that, I have negative 8x cubed minus 8x squared. Subtract, and I get, well, that becomes 14 plus 8, which is 22x squared. plus 2x. How many times does x go into 22x squared? Well, it goes in plus 22x times. Multiply that, bring it down. I get this. Subtract 2x minus 22x is negative 20x, and then minus 20 at the end. How many times does it go in? It goes in negative 20 times. Multiply it, and yes, this is going to work. That's great. So I divided it, and here's what I'm left with. X cubed minus 8x squared plus 22x minus 20. I can do another division with that, and I have to actually. This is not a quadratic yet. I need to divide it by one more thing. The good news is I have another 0. So this tells me 2 equals x. If I subtract 2 from both sides, I get x minus 2 equals 0. That means my function divides by x minus 2. So I should divide it by x minus 2. And if I do that, I get it goes in x squared times, let's see, x cubed minus 2x squared, subtract, I get negative 6x squared plus 22x. How many times does it go in? Negative 6x times. That's negative 6x squared plus 12x. Subtract. 22 minus 12 is 10x minus 20. That's a plus 10. And that works. Subtract, I get 0. Okay, I am down to a quadratic. So let me back up. Here's what this means. My function, this whole long thing, x to the fourth minus 7x cubed, you see it, that whole function is equal to x plus 1 times x minus 2 times this guy, what I have left, x squared minus 6x plus 10. So it is equal to x plus 1 times x minus 2 times x squared minus 6x plus 10. I have factored it down much further than it was. For this last piece, I'm going to find my zeros. Let me give myself some more space. I'm going to find my zeros using the quadratic formula. So I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Inside my quadratic formula, I have 36. Negative 6 squared is 36. 4 times 1 times 10 is 40. All right, here's where the complex 0 comes in. 36 minus 40 is negative 4, which means I'm going to have to write it as an imaginary number. The square root of negative 4 is the same as this. It's the same as the square root of 4 times I. So you take the negative, basically, and you move it out, and then you call it I. That's how we find complex anything. When you have the square root of a negative, we just get rid of the negative, we call it I. Get rid of the square root of a negative, we call it I. From here, it simplifies. 6 plus or minus 2i divided by 2. Everything divides by 2. That is 3 plus or minus I. So I found it. Those are my two complex zeros. 3 plus I, 3 minus I. So my function, what did they say? Did they say write it as a, no, they didn't say write it as a product of linear factors. We're done. We've done it. The complex zeros are these two. We used our rational zeros theorem to list, we did it out of order, but that's fine, to list all the rational zeros. We divided out the ones that we found, and we used our quadratic formula to find our two complex zeros, and there they are. Okay, last one. Use the rational zeros theorem to list the possible rational zeros for each of the following. Well, let's see. For A, it's always a fraction, remember? And the top of the fraction comes from the 18. So the numerator has to be a factor of 18. Well, what are all the factors of 18? 1, plus or minus. The numerator possibilities. 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9, not 10, not 12, I think from there it's just 18. Yeah. Hang on. 6 times 3, 2 times 9, 1 times 18. Yeah, I think that's it. The denominator has these possibilities, 2 or 1. So the denominator could be plus or minus 1, plus or minus. We don't need to also include the plus or minus there. It's taken care of. If the numerator is plus or minus, the whole fraction is plus or minus. So my possible zeros, or my rational zero candidates, are plus or minus 1, plus or minus 1 over 2, plus or minus 2. And then I could say plus or minus 2 over 2, but that's just equal to 1, so I don't need to add it. Then we got plus or minus 3, plus or minus 3 over 2, plus or minus 6, plus or minus 6 over 2. But again, 6 over 2 is just 3. It's already taken care of. Let's move on. Plus or minus 9, plus or minus 9 over 2, plus or minus 18. And again, plus or minus 18 over 2, that's just 9. It's in the list. This is a complete list. All of my possible rational zeros. All right, for B, we're going to follow the same process, but the good news is it's a little simpler. 19 doesn't factor nearly as well as 18. 19 is prime, so its factors are plus or minus 1, plus or minus 19. So our numerator could be 1 or 19. Our denominator could be, I guess I should put plus or minus, but it doesn't matter. Our denominator, 1 or 5. That's it. Those are all the factors of 5, which means our possible zeros are, and let me write this, our rational zero candidates are 1, 1 over 5, 19, 19 over 5. Done. Okay, use synthetic division and the remainder theorem to find the indicated function value. Well, I don't like to write my my synthetic division exactly like this. I would usually write it out. So I would do the 47 and the 18x and the negative 12x squared and the negative 2x cubed and the x to the fourth. You do not have to write it all out. If you prefer to leave it like this, that is totally fine. Actually, it's probably simpler to keep track of just the numbers, but I like to know exactly what I'm doing. So I'm dividing this function by x minus 3. Okay, so it says, by the remainder theorem, state the value of f of 3. Oh, so I'm just going to do this division, and whatever the remainder is, that is f of 3. So let's see, it goes in x cubed times, and then I have x to the fourth minus 3x cubed, negative 2 plus, that's x cubed, and then minus 12x squared. So it gets plus x squared. That is x cubed minus 3x squared. Subtract. Negative 12 plus 3 is negative 9x squared plus 18x. That is minus 9x. Negative 9x squared plus 27x. Subtract those, I get negative 9x plus 47. So it goes in negative 9 times. That is negative 9x plus, nope, it is plus 27. Subtract, I get 20. F of 3 is 20. Done. This would be the same. 2x cubed minus 5x squared minus 23x minus 10. It says use synthetic division. That means divide it by x plus 3. It's always x minus r0. X minus -3 is x plus 3. So we're just going to use synthetic division, and then whatever the remainder is, that is f of -3. So, okay, we've got 2x squared, and then that gives me 2x cubed plus 6x squared. Subtract 5 minus 6, that's -11x squared minus 23x. That goes in -11x times, that's -11x squared minus 33x. When I subtract -23, that would be 10. So x goes in plus 10 times, that's 10x plus 30. Subtract, I get -10 minus 30, that is -40, which means f of -3 must be equal to -40. Okay. Suppose a polynomial function of degree 4 with rational coefficients has zeros of -4, 1, and 2i. Find the remaining 0 and write the polynomial function as a product of linear factors. Well, here's the rule. Complex zeros always come in pairs. They always come as a plus and a minus. Complex zeros always come in pairs, which means this 2i is missing its buddy, and its buddy is minus 2i. You always just, whatever part has I, so if it was 3 plus i, the complex zero would be minus i. It's just the same thing, but make the I part negative. That's all. So our zeros are -4, 1, 2i, and -2i, which means we can just write the linear combinations like this. X minus -4, x minus 1, x minus 2i, x minus -2i. That's it. That's our function. You could simplify this, but we're basically done. This is x plus 4, x minus 1, x minus 2i, x plus 2i. Done. Let's see. I thought there was another one that had finding complex zeros. I guess not. Okay. I'm going to call it there and come back in another recording.